Welcome to This Explainer. Today, we are decoding the blueprint of the smartest buildings in the world. We're going to treat these spaces not just as structures made of concrete and glass, but as living, breathing organisms designed to interact with us and the environment around them.
So let's start with a provocative question, shall we? What actually makes a building smart? I mean, does it happen just by packing a ton of computers inside, or is it something much deeper? Is it just about having blazing fast Wi-Fi, or is it about how the physical structure itself understands its own state and its occupants?
Well, let's dive into this by defining what we actually mean by building intelligence. Basically, it's a totally integrated approach. It merges advanced telecommunications, office automation, and building automation to create a convenient, comfortable, and highly productive environment. It's this perfect harmony of management, security, and energy conservation. Here is our roadmap for today's explainer. First, the static shell. Second, powering the built environment. Third, the building's senses. Fourth, the central brain. And fifth, the human factor. Okay, part one, the static shell. Think of this as the skin and foundation of our building. Think about this number for a second, 60%. Simply providing a well-insulated roof and properly designed walls can reduce heat creeping in by up to 60%. So before we plug in a single computer or wire up a sensor, the building's intelligence literally starts with its basic physical shape, basically saving us from feeling like we're working in a giant greenhouse. So how does this shell actually come together? It starts with an architect generating forms on a CAD, or computer-aided design station. But they aren't working in a silo. They're electronically linked for continuous consultancy with engineers, interior designers, and construction managers. This rapid, real-time testing of layouts and materials means they can reach a final, commonly agreed-upon solution that bakes energy savings right into the very bones of the structure. Moving right along to part two, powering the built environment. These are the lungs and circulation of our structure. To power up efficiently, these massive organisms tap into clean, completely free energy using the sun in two very distinct ways. First, solar thermal energy is used directly for heating and cooling. Second, solar light, or photovoltaic cells, is used to generate actual electric energy. And what's so amazing about this is that solar panels have zero moving parts. They collect power without adding fuel or constantly needing worn-out components replaced. It's just silent, constant energy. Now, once we have that power generated, the absolute crucial next step is managing the HVAC. That's heating, ventilation, and air conditioning. This is the core system used for climate control. Its entire purpose is to maintain a comfortable atmosphere. Making sure you're not shivering at your desk or sweating through your shirt. But to make this HVAC system truly smart, engineers introduce what's called a variable frequency drive, or a VFD. Instead of an air conditioner just blindly blasting cold air at one constant speed, the VFD automatically adjusts the motor speed of the cooling system in real time. It reacts directly to the ambient temperature outside, which results in significantly lower cooling loads and, as you can imagine, massive energy savings. Which brings us to part three, the building's senses, basically the nervous system. For a building to really interact with its environment, it needs nerve endings. Intelligent buildings integrate environmental control into a single, cohesive system using a network of external sensors. These sensors are constantly monitoring absolutely everything: temperature, wind speed, exactly how much daylight is coming in, what the artificial light requirements are, humidity, and even smoke levels for immediate fire protection. Okay, this is where it gets truly fascinating. The system actually tracks a phenomenon called thermal lag. This is essentially the delay in a structure's internal temperature change compared to the weather outside. Because the main computer monitors this every single hour of the day, every day of the week, it perfectly anticipates when the building will naturally heat up or cool down. It adjusts the systems proactively rather than just reacting after it's already too hot or too cold. Next up is part four, the central brain. This is all about total autonomy. Achieving total control of a building's operations generally comes down to two main approaches. First, you have a centralized system where one single, powerful master computer manages the entire building. Alternatively, you can use a distributed, autonomous system. In this setup, specific local areas possess their own full computing capability and local intelligence, allowing different zones of the building to operate totally independently based on their unique, real-time needs. When you break it down, building intelligence really operates across three key overlapping dimensions. First, there's office automation, which fulfills sensory and social needs right at your workstation. Then you have telecommunications, handling seamless voice and data integration. And finally, building automation, which manages security, power, and energy conservation. It's the effective management of all these resources, working in coordinated mode, that maximizes the initial investment and drastically lowers operating costs.
And finally, part 5, the human factor. This is exactly why all of this matters. This is kind of the climax of our explainer, right? Because literally the smartest, most technologically advanced building in the world is completely useless if it doesn't serve its primary purpose, you, the occupant. It's entirely about guaranteeing specific comfort factors. We're talking controlled lighting to avoid screen glare, comfortable furniture, and optimum space utilization. It's about ensuring the perfect temperature of air circulation and providing a trouble-free working environment that actually keeps you healthy. The source material actually sums this up perfectly, stating that productivity depends on internal refreshing environment with comforts. At the end of the day, things like job satisfaction, income, and overall human productivity are directly tethered to this carefully crafted environment. If the building is truly smart, the people inside it can perform at their absolute best. As we wrap up this explainer on the anatomy of an intelligent machine, it leaves us with one thrilling final thought. We've just seen how these incredible structures have already developed a protective skin, efficient lungs, highly sensitive nervous systems, and autonomous brains, all focused entirely on human productivity. So, if our buildings are this intelligent today, what will they be thinking tomorrow?